To help out with the test you guys are about to take, I thought I should do some problems for you. So for the first section, you're supposed to differentiate some stuff. So let's differentiate tangent times 2x, tangent of 2x to the fourth. So let me do that. So typically, the derivative would be secant squared. But because we have a thing inside, we have to take the derivative of that first. So that would be, not first, but we would have to take the derivative of that. So it would be 8x to the 3 power. So your answer will be this. And we would call this essentially a chain rule problem. Alrighty, so let's do another one. Probably, let's do this one right here. That one might be a little bit difficult. So tangent inverse, I believe, I'm going by memory now. I think that the derivative was 1 over, and then 1 plus x squared. I'm gonna have to double check whether that's true. Is that true? Oh, okay. Yeah, that is true. Because I'm looking at what the answer is supposed to look like. Alrighty. So tangent inverse would have a derivative, dx dy, dy dx of this. But because it's not x, it's like 2x to the fourth, it would be this. Now the only problem is, remember that we have to deal with chain rule. So you will have to end up multiplying your answer by the derivative of whatever was inside, which was 2x to the fourth. That would be 8x cubed, which is why our final answer is 8x cubed times 4x to the fourth, 4x to the eighth plus 1. So that was kind of easy. So let's move on to the next thing. And we have more like that. I mean, this one might be more advanced right here. That's a product rule with chain rules. In that case, I'm just going to do this one real time. So I'm going to ignore the 7. Just going to put the 7 on the very outside. Derivative of the first, which will be 2 sine of 2x with a negative, times the second, sine of 6x, plus, and then derivative of the second times the first. That would be 6 cosine of 6x, and then times the first, which will be cosine of 2x. And then you guys you're just going to simplify it a bit, probably multiply it through, which would be, yeah, that would exactly give you this answer. So if you actually multiply the 7 here and there, you should get the exact same answer. So let's move on to the next thing. I believe the problem I didn't do was here somewhere. No, come on. Let's zoom in right there. Alrighty. Some people might have been still confused about how to do this one, so let's do this one real quick. Alright, so the way it works is we take a derivative of this part, this part, this part, and this part. And this part is going to end up being 0, so that's no problem, which is why I didn't even bother mentioning it right here. 2x to the third is, let me use the highlighting feature, is 6x squared. And then negative 5x squared is negative 10x. But when it comes to taking the derivative of this guy, we have to be a little bit more tricky because it has a y in it. The y exists. So let's figure this out. So the first thing we're going to do is to take the derivative of the first part, which will be 3x squared times the second. And then we do derivative of the second times the first, but this one's a little bit going to be trickier. 2y times 4x cubed times y prime. Now I'm going to double check whether I did it correctly and double check with me. So the derivative of this one is 3x squared, boom, multiplied by the second, y squared, boom. And then the second part, the derivative of this is, let me use a different color, of y squared will be 2y times the first, 4x cubed. Alrighty. And because I did the derivative of y, I have to make sure to add the y prime. Okay, I did it correctly. Now what I probably want to do is get the 4 in there and then also put it all in here, which I'll do right now. Alrighty, so I kind of did it. I just want to point something out real quick. Over here, over here I had a 4, which is this 4 right here. Let me use a different color. I pretty much did the derivative of this times 4x cubed, which is weird because the 4 is out here already. So it's just 2y times x cubed, which is 2y x cubed, and then times y prime. So when you get the 4 in there, you're going to end up with 8y y prime x to the 3 power, or however you like to order this. So let me go ahead and make some space now that we have that taken care of. Okay, so let's make this look nicer now. I'm gonna go ahead and get all of this stuff, leave out. See, here's what I'm gonna do before I pause the video and do my thing. I'm gonna move this over here, I'll move that over here, and that's all I'm gonna do. Alrighty, so I did that. A few things I'm gonna do real quick is divide both sides by 2. I was gonna divide both sides by x. So that's gonna make some stuff look better. This is gonna end up being 3x plus, and I think that's a 8. That's an 8x, no, 6. That's a, simple math, come on. Okay, 3x plus 6, I was gonna write 8 again. 8x y squared plus 5 equal, and that will end up being 4y x squared y prime. Divide by 4y x squared. Divide by 4. Oh, I made a mistake. What mistake did I make? That's negative. When I took this over there, it should have become a negative. So that's negative, which means that's negative, that's negative, that's negative. And I think that's it. That's compared to the actual thing. So we have 5, 3x, 3x, 6x y squared, 6x y squared, 4x squared, y, 4x squared y. Yeah, it's the exact same answer. If you put this one or that one, you get full credit. They both mean the same thing. If you know anything about that, is if I multiply both sides, top and bottom, by -1, I would pretty much make it look exactly like what the answer shows. Alrighty, so that was that. And the last problem I'm going to do right here is, I believe it was this one. Alrighty, so that's the next problem I'm going to go over. Alright, so let's read this problem properly. As a beacon light at the airport rotates, it casts the point of light onto a building located 200 feet northeast of the beacon. I don't know what that means, to be honest. Apparently, what that means is that if, for this triangle, I don't even know what a beacon is. A beacon light at an airport. Hey, what's a beacon?
A beacon?
Yeah. Don't worry about it. Let me just Google that real quick. So I looked up what a beacon is. Apparently, this thing is a beacon. And I had to look up what a building is. Apparently, that's a building. No, I didn't have to look up the building. But this is definitely a horribly worded problem. Because, honestly, I'm from a different country. And I could have made this problem sound a lot easier. Anyways, I digress. So the beacon is 200 feet away from the building, and then we're shining a light, which essentially the light moves up the building, and we're gonna call that variable as how far the light goes up, y, and the degree we're gonna call. Oh God, let me go to my highlighter. We're gonna call that variable how far it moves up, y. Well, that's gonna be in the video. How far it goes up, y, and then we're gonna call the degree x. All right, and let's do this. I think one of the thing we talked about that kind of got a few students confused is the whole dy. Oh, oops. Let's get the pen going. The whole dy dx, dy dt, and dx dt, and what those things really mean in this case. So we just talked about it. X is radians, it's degrees, and y is feet. So dy dx is the rate of change that, and let me use a highlighter. Dy dx is the rate of change at which this thing moves per degree, not per time, but per degree. So as x changes, how would this change? So essentially, it's a speed that doesn't really have time in it, which is not really the definition of speed. But that could be confusing. But if you kind of write down dy dt and dx dt, that's more proper when it comes to speed, because t is time and y is feet. So dy dt is literally how fast you move up per second. And that's going to be different, of course. And dx dt is how much this is changing, or let me use a different color, how this is rotating per second. So that's the speed in radians per second. So feet per second, radians per second, that would be dy dt, dx dt. And if you remember from the notes, dy dx equals dy dt over dx dt. So I didn't actually do the problem. I just gave you guys a little spiel on what dy dx is, dy dt, and dx dt. And I highly encourage you to go back to rewatch it. So where this one would be feet per radians, which doesn't have time in it, not necessarily speed, but it is a rate of change. As one changes, the other changes. Dy dt is feet per second. That's how fast you're moving upwards. And then dx dt is radians per second, and that's the speed in radians, the angular speed, if you will. And that's the relationship between dy dx with dy dt, dx dt. Alrighty, so let's continue reading the problem. Let x be the angle, let the light be mixed with the east, blah, blah. Let y be the number of feet north of the line where the point of light shines when the angle is x. So, find dy dx because y depends on, find dy dx, which I can easily do, because x depends on t. X is an inside function. You will need to apply the chain rule and the answer will contain dx dt. Alrighty, so when we looked at the triangle, we had a triangle. When we looked at the triangle, we have 200 y, 200, and we have x. So if I was to use my trigonometric knowledge, tangent of x equals y over 200. And if I kind of make it look nicer, that would end up giving me y equals 200 tangent of x. So dy dx would be 200 secant squared of x. But keep in mind that that really is the same thing as this one right here. So dy dt over dx dt equals 200 secant squared of x. That becomes important later. Suppose that the beacon is rotating counterclockwise at, now we have the speed, we have dx dt. So we have dx dt equaling 0.3. How fast is the point of light moving along the wall when it passes the window located at 400 feet? So it's not properly written, but pretty much what they're asking is, what's dy dt? That's what they're asking. And that's what we're going to be looking for. In order to find that, we need to know what dy dx is, because dy dx equals dy dt all over dx dt, which that one equals 0.3. So let's find out what that dy dt is. So when y is 400, we have 400 equaling 200 tangent x. So 2 equals tangent x. So arctangent x equals arctangent or tangent -1 of 2. So you have that. I'm just going to write it the other way. Tangent -1 of 2. I'm going to leave it at that. I know it's like 1 point something, and plug it into my dy dx, which is dy dx equals 200 secant squared of tangent inverse of 2. And the calculator should give you 1,000. That's the answer for dy dx. Now, let's put that in here. So that would be 1,000 equaling dy dt all over 0.3. Multiply 0.3 on both sides. Dy dt equals 300 feet per second. Now, because we're trying to have 3 decimals, you'll probably put 0.000. Alrighty, that is it. That's how you do this problem. The answer is 300. I know that this question was confusing in class, and I realize that when I give you guys a test on Wednesday, I will make sure that this is more proper. This is totally unacceptable. This problem, I don't like at all. The way, I didn't know what the beacon is, so that's a weird thing. And I'm gonna draw the picture for you, because Mr. S can do nice things from time to time, and you guys are a meaningful group that I kind of care about. So I'll do that for you guys, okay? You guys have a fantastic day, and enjoy watching this video over and over and over again.